Ever found yourself lost in the beauty of the night sky, staring at those twinkling stars and wondering what they really are? They might look like tiny, sparkling jewels scattered across the vastness of space, but trust me, there's so much more than just pretty decorations up there. These stars have a profound connection to us, to our very existence, and to the mysteries of the universe itself. So, why exactly are there so many stars in the universe, and what makes them so important? First off, let's talk about the sheer number of stars out there. Modern astronomers have tried to count them all, but it's an impossible task. There are just too many. However, they haven't given up on trying to estimate the number. And guess what? There's an age-old question that often pops up. Are there more stars in the universe or grains of sand on Earth? Sounds like a fun, simple question, right? But it's one that scientists have seriously tackled. After much research, it's estimated that the number of stars in the universe is around 7 times 10 to the power of 22. That's a 7 followed by 22 zeros, a mind-blowingly huge number. To put it into perspective, imagine trying to write down the number of stars on sheets of paper, with each sheet holding 1,000 dots. You'd need 7 times 10 to the power of 19 sheets of paper, which is enough to cover the entire surface of the Earth. But let's think of it another way. Picture this. If each star were represented by a grain of rice, with each grain being about 5 mm in size, and knowing that 1 kilogram of rice contains about 50,000 grains, how much rice would you need? You'd need about 1.4 times 10 to the power of 18 tons of rice, enough to cover the world several times over. Now, compare this to the grains of sand you can scoop up with your hands on a beach. An adult can hold about 5 to 8 million grains of sand. Scientists estimate that there are about 7 times 10 to the power of 18 grains of sand on all of Earth's beaches and deserts combined. This means that the number of stars is about 10 times greater than all the grains of sand on our planet. Amazing, right? Now, if you tried to count all these stars, one per second, it would take you about 2 trillion years. And that's just the stars in the entire universe. If we focus only on our galaxy, the Milky Way, which has between 200 and 400 billion stars, it would still take around 400,000 years to count them all, one by one. Even if you started counting the moment you were born and kept counting every second until your last breath, you'd only get through about 3.15 billion stars, not even 1% of our galaxy. It's mind-boggling to think about. But what's truly fascinating is how these stars are connected to us and everything around us. Without stars, there would be no planets, no Earth, and no life as we know it. Stars are like the universe's engines, creating and spreading the essential elements and energy needed to form everything in existence. From the very beginning, stars have been working non-stop, producing matter and energy, which they then release into space. These materials eventually come together to form planets and moons, creating the perfect conditions for life to emerge. So in a way, stars are our cosmic parents. But just like living beings, stars are born, grow, evolve, and eventually die. Even though a star's life can span billions of years, far longer than our human lives, it's still just one life cycle in the grand scale of the universe. Understanding how stars are formed helps us appreciate their importance even more. After the Big Bang, the universe started expanding with an incredible amount of energy. In its early days, the universe was extremely hot and dense, but as it cooled, the first elements like hydrogen and helium began to form. These elements were spread evenly across the universe, but over time, gravity pulled them together, creating denser regions. These regions eventually formed massive gas clouds, which began to collapse under their own gravity, heating up and forming the core of a new star. As the gas cloud collapses, the temperature at its center rises dramatically. When it gets hot enough, millions of degrees, the process of nuclear fusion begins. This is when hydrogen atoms combine to form helium, releasing enormous amounts of energy. At this point, the star starts to shine brightly, entering what's known as the main sequence stage. During this stage, a star remains stable for billions of years, steadily burning hydrogen into helium and shining brightly. Our Sun is currently in this stage and will continue to shine for billions of years to come. But not all stars have the same life story. A star's mass is the key factor that determines its fate. Stars like our Sun with intermediate mass will eventually run out of hydrogen in their cores. When this happens, the core contracts while the outer layers expand, turning the star into a red giant. In this phase, the star swells to many times its original size and its surface cools, giving it a reddish glow. For stars like the Sun, this red giant phase leads to the outer layers being blown off into space, leaving behind a hot, dense core that becomes a white dwarf. White dwarfs are incredibly dense and slowly cool over time, eventually fading away. Our Sun will follow this path in about 5 billion years. But for stars much more massive than the Sun, the story is more dramatic. These massive stars can fuse heavier elements like carbon, oxygen, and silicon as they evolve. However, when iron builds up in the core, fusion stops, and the star can no longer support itself against gravity. This leads to a spectacular explosion known as a supernova. A supernova is one of the most powerful explosions in the universe, releasing as much energy in a few seconds as the Sun will produce over its entire lifetime. What's left behind could be a neutron star, or, if the star was massive enough, a black hole, a region of space with gravity so strong that not even light can escape. The life and death of stars aren't just about the stars themselves. They have a profound impact on the universe and on us. Stars create the elements that make up everything around us. During their lifetimes, stars fuse lighter elements into heavier ones in their cores. For example, the carbon, oxygen, nitrogen, and iron that make up our bodies were all formed inside stars. When a star dies, especially in a supernova, these elements are scattered into space, where they can form new stars, planets, and even life. So, in a very real sense, we're all made of stardust. Isn't it incredible to think that every atom in our bodies was once part of a star? The stars are more than just distant points of light in the night sky. They're the building blocks of life, the universe's way of making sure that everything, including us, has a place in the cosmos. So next time you look up at the night sky, remember, you're gazing at the very stuff that makes up the universe and ultimately yourself.